So I want to talk about the invalidation of iterators in a vector. So let's say we have a vector and I'm going to create a vector of integers, for example. Let's populate the vector with a bunch of numbers, doesn't matter. And yeah, so if you wanted to iterate over this vector, we would create a vector of the same type. So we'd say vector int ::: iterator. And you can name this iterator anything basically, but yeah, it's logical to go with the with something like it to make it obvious. So how do you use that iterator now to iterate over the vector? Well, you use something like a for loop, like you normally would, to iterate over anything. And instead of something like int I equals something something, you instead use the iterator that you created. By the way, you could create the iterator in there as well, like you do with I, or you could create it outside, and it's obviously more cleaner to create outside. You can also use auto here if you wanted to, but for demonstration purposes and to make this code more readable, it's better to spell out the type. Okay, so we're going to say iterator it is less than, not equal to num.end. And one thing we forgot to do here is set a value, a starting value for this iterator, which would be the beginning of the vector. So num.begin, and like we do with an integer, we do it ++ here. So now, first let's just print all the, as we go through the elements in a vector, we print them out. So the way you do that is by dereferencing the iterator, because the iterator is pointing to an element, so it's like a pointer. So you still need to dereference it. And all. Now let's just create an arbitrary example. So for example, if you wanted to say, if we come across the number 3, then I want to delete that number. So we look for something like this. So if it, or rather the value that the it is pointing to, so we dereference it, is equal to 3, then what we want to do is erase that element. So the way you do that is use the erase function, and you just you just pass it the iterator, like so. And also let's just print the value at this iterator once we've done that, and see what that does. Right, so let's just run this and see what happens. So, well, I don't know what this is doing. I'm just going to close this and rerun it, because it just did something strange. Right, so if I pull this over, you can see that it's crashed and it's printed something here, but it's not everything that you wanted to print. So we have 1, 2, 3 printed. So we got to the third element, and then we didn't print anything else after that. And obviously, because we're checking for 3 and we're erasing that, it's obvious that that's what's causing the issue. But why is it crashing? So if you were to take a look at the output, you won't really be able to tell, what's going on here. Exception thrown, read access violation, that could be anything. And the output really doesn't help you here. But if you were to take a look at the call stack, you can see that the error is happening at line 23. And what's happening at line 23? We are trying to print out the value stored at this iterator. That tells us where the error is occurring, but it doesn't really tell us what's happening. So let's just comment this out and rerun this thing. Okay, so it crashed again. So we're still printing 1, 2, 3, and we're crashing. But if you were to come down and take a look at the call stack again, it's now saying it's happening at line 16, which is different to what it was saying before. Before it said the error is happening at line 23, but now it's happening at 16. So what's happening at 16? Well, we're trying to access this iterator again. And what's common in these two lines? Well, it's that we're trying to use that iterator. So that should give you a hint as to what's happening here. Obviously, this video is about the iterators getting invalidated, so you know what's happening. But if you were to, gauge without knowing, then this is how you would try to triangulate. That was a lot of tries. Triangulate the error by looking at things that, comment out things where the error is occurring before, and if it's still occurring, then try to find out what's common in those places. That's just one way to try and figure out errors. You can do those other ways, of course. So what do you do to fix this then? So one thing we could do, and we'll go through a more long-winded way to begin with, and what I'm going to do is I'm going to create another iterator. Actually, if you were to hover over this erase function, and we are in run mode, so we're not going to do that. If you hover over the erase function, you're going to see that it returns an iterator. And so we can capture that iterator in a new iterator. And to do that, I'm going to use the auto keyword this time, so I don't have to type this entire thing out. Auto new it is equal to that. And if I were to then try and print the new int rather than iterate the it itself, let's see what happens. Okay, so now it's printing 1, 2, 3, 5, which is the fourth element, I guess. So it managed to get one element ahead, but it still crashed. And if you were to take a look at the stack, it's saying it's crashed at line 16. So it's still crashing here because we're still trying to use the iterator. So we didn't replace this with new it, so let's do that and fix it. So I'm going to say it is equal to new it. And that should fix it. So no more errors, and that fixed it. But we could do it in a shorthand way. We just do not create this new iterator at all. We could instead just pass it directly to this iterator right here. So we can just say it is equal to whatever is returned by erase, and that's going to be the iterator after this one. So if you run that, we're going to see all the elements, but wait, that's not all the elements. We only see 1, 2, 3, and 56, and that's because the iterator that was pointing to 5 never got to this place. Because when we erased it, this iterator would now be pointing at 5, but when it goes up to this loop, it's going to do an it++, so then it's going to point to the next element, and when it comes down to this line, it's now going to be pointing to 56 rather than 5. And you can test that quickly by putting a breakpoint here, and if I run that now, well, obviously we're going to have to go through a bunch of iterations. So we've gone through 1, 2, 3, and now if you hover over it, it's at the moment saying it is pointing to 3. If I run that, oops, what have I done? If I go in here and if I run that, and now it says it's pointing to 5. And if I do F11 again, it's still pointing to 5. Come down here, and it's now pointing to 56. And that's because we did an it++ here, and that's going to increment the iterator, so it's no longer going to be pointing to 5. So we're going to skip 5 here. But it's not that that 5 has been removed from here. What's been removed is number 3. But what we see here is 3 being printed because we were printing it before. So if we were to print the entire vector out, for auto I in the vector, then what we're going to see is I'm just going to add a string here just to clarify where this is coming from. If you run that, so now you can see the elements of the vector are 1, 2, 5, and 56 because we erased number 3. Now what's another situation where you can have the iterator invalidated? So the iterator gets invalidated whenever you change the shape of the container, and that could be either by erasing something from the container or by adding something to it. So if I were to, instead of erasing something, if I were to do something like num, and let's just get rid of this now for the moment, num dot push back, and let's just add a new number to it, 8. Okay, and if I were to run that, it's still gonna, give me an error because we changed the shape of the container. So error is coming from line 16, and you don't really get to know what the error is because again it's just read access violation, so it doesn't really help you there. Okay, but we know the iterator is getting invalidated, so how do you fix that? Well, if you hover over, if I just send this, if you hover over the pushback function, you can see it returns nothing. So, what do you do now? Because with erase you could just capture the iterator that returns and set the iterator to that iterator. But now you don't have one, so what do you do? Well, it's a bit, if you're a performance junkie, then you might not want to do this, but what we do is insert. And insert isn't going to be as expensive in this case because we are already iterating of the vector, so we can afford to insert something at that location. And insert, and what you pass in there is the iterator and the value that you want to insert. So let's just add something like 8 at the location, right? And I also want to bring back the if you hover over insert, you can see that it's still, that it also returns an iterator. And I want to bring back the printing of the value right after, so you can see what's happening. And if I run this now, you can see it goes up to 1 to 3, and it breaks and it crashes. And that's because we obviously did not set anything to it yet, the iterator to anything. So we're going to do that now. Iterator is equal to that, and we run that again. And something interesting happens here. You're now getting a bunch of 8s and 3s. So what's happening there? It was so hard to tell what it was because when it was running, the 3 was blending in with 8, so probably bad choice of numbers there, but yeah. You're stuck in an infinite loop now. And why is that? So let's take a look. So when you do an insert, and you're inserting something at that location, so where 3 was, we're now inserting 8, right? And what this does is it moves 3 over to the next location. So if you inserted 8 at the location of 3, now the vector is going to look something like this, right? And the iterator that insert returns is going to be whatever this iterator was pointing to plus 1. So this iterator was pointing to this location where 8 is now, and it's going to return the iterator that's pointing to the next location, which is where 3 is. And as you can see, when we come back to the next iteration of this for loop, it's going to check whether the next iteration is pointing to 3, and it is, of course, because we moved 3 over to the next location in the vector. So we have essentially created a very clever for loop. It's not hard to see, sorry, an infinite loop, because it's not hard to see there's an infinite loop here, but there is, because this is what we're doing. So how do you fix that? One way you could do that is by, doing something like that. So you can add this 8 ahead of the 3, or you can choose to add it before the 3. And if you don't want to do that, if you really want to add this element right where 3 is, then you could just leave this as is, and you can down here we can do it minus equals it, something like that. It's up to you. Oops, not it. It minus equals 1, right? But I think I prefer doing, like, because it doesn't really matter if you add it before or after 3, unless you really want to, you have like a special case where you want to really put this element in that location, which doesn't make sense. So I would either put it in front of 3 or after it, and I could do it like that, like so. So if I run this, you can see that if I bring this over, it's doing 1, 2, 8, 3, 8, 5, 56. So what's going on there? So I forgot to remove this, of course, so that's going to be a bit confusing. We could just run that again just to not make this example confusing, so I'm going to do that. So now you can see it's printing 1, 2, 3, 8, 5, and 56. 1, 2, 3, and it's printing the 8 as well, and 56. So that was a very long explanation of the invalidation of an iterator. I think it's worth going through all these errors and how do you figure out what's happening and stuff like that. So I think it's worth making an explanation long when you can see the process it involves to debug something like this. So yeah, that's it for this video.